Okay, so today and for the next few days for math, we're going to take a departure away from your math workbook. We are going to come back to it, but we're going to use a different math book that might look familiar to some of you. It's a different math curriculum called Go Math. Give me a thumbs up if you remember using Go Math at some point in your life here at Stockmeyer. Yeah, okay. We're just going to do a couple Go Math chapters, and, you know, we're in Module 5 for our regular math book, but same material. We're going to take a little detour and do Chapter 11 in Go Math. Okay, so this is Chapter 11, Lesson 1. That's why it's 11.1. Make sense? And your learning goal today is, by the end of math today, I want you to be able to identify, meaning I can name different polygons and I can classify them. Classifying means to put them into categories or put them into groups. Our problem of the day says that there's this building called the Castel dei Monte in Italy, and it's built more than 750 years ago. And as you can see in the picture, the fortress has all these surrounding pillars. Do you guys see them? And in the middle, there's like one, right? So the problem of the day is asking you, what is the name of this central, or you could look at it there, or of this central building, okay? To think more about our problem of the day, here's what you need to know, okay? And even though these notes are in your packet that I just gave you, I want you to write this definition in your notebook. A polygon is a closed plane figure. Plane means it only has one dimension. Plane means 1D, not 2D. Oh, sorry, 2D, not 3D, not 1D. It's 2D, okay? It's a flat, it's on one plane, and it's formed by 3 or more line segments. 3 or more line segments. Please also note that it needs to be closed. That meet at points called vertices. So that's another vocab word, actually. The points where the different lines meet are called vertices, and we talked about that word yesterday. Polygons have different names, and they are named by the number of sides and angles it has. Okay? Is this figure in black a polygon? Yes or no? No. Why not? Well, for one, is it closed? No. For another, how many lines does it have? 2. And how many line segments does a polygon need to have? 3 or more. So if this only has 2, it doesn't, and it's not closed, it's not a polygon. What about this one in red? Is this a polygon? Yes. It has how many line segments? 4. How many vertices does it have? 4. So here are the line segments. 1, 2, 3, 4. Here are the vertices. 1, 2, 3, 4. How many angles does it have? Angles are these, what's formed by the 2 line segments meeting. So how many angles are there? 4. Is it a polygon? Yes. Yes. Is this one in blue a polygon? No. How many line segments does it have? 1. How many line segments does it have? 0. None. 0, because it is a curve, it's a circle, and a circle is not a line. What about this green one? Is that a polygon? No. How many line segments does it have? 1. Is that 3 or more? No. Is it closed? No. No. This repeated polygon has how many sides? 2, 3, 4, 5, 6, 7, 8. How many sides does it have? 8. Okay. How many angles does it have? 1, 2, 3, 4, 5, 6, 7, 8. How many angles? 8. And how many vertices? 1, 2, 3, 4, 5, 6, 7, 8. So, what do we call that kind of polygon? Octagon. Good. The octagon is the repeated polygon in the Castel del Monte because it has 8 sides, 8 angles, and 8 vertices. Now that you know that a polygon is a closed 2D figure, you need to know that there are special kinds of polygons called regular polygons. Everyone say regular polygons. Regular polygons. Okay, this is time for notebooks. Okay, so regular polygons are when line segments and angles are all congruent. What does congruent mean? The same. So here's how you might write it. You might write regular polygons equals all angles and lines are the same. That means all the lines are the same length and all the angles have the same measurement. They are all congruent. Congruent is another math vocabulary word that I'd like you to write down. Congruent means all the same. What kind of polygon is this? How many sides does it have?
5.
5. How many angles does it have?
5.
How many vertices does it have? So what is this? We call it a pentagon. If you ever forget, you can look at your chart to see what they're called. Okay, you're going to want to memorize them though. Now it says all the sides are congruent. That means that all the lengths are the same size. How long is it from here to here? 4 centimeters. How long is it from here to here?
4 centimeters.
How long is it from here to here?
4 centimeters.
How long is it from here to here?
4 centimeters.
And from here to here, it is also.
4 centimeters.
Are all the sides congruent?
Yeah.
Now, how did this person who labeled this diagram show you that it was congruent? They labeled each side 4 centimeters, 4 centimeters, 4 centimeters, 4 centimeters, 4 centimeters. If they didn't do that, if they just drew it like this, could you assume that all sides are the same? No. Especially when you're drawing, if I intend for all 5 sides to be the same, it can be really difficult if I'm not using measuring tools, right? So to show it, if you want to show that all sides are congruent, you have 2 choices. You can either label all the sides like this, or you can use a shortcut symbol. We're always into those, right? I can show by drawing one line through each, and because I'm doing the same kind of marking, I'm showing that those are congruent. Those sides are congruent. Does that make sense? Go ahead in your notebook right now, draw yourself a pentagon, and then draw those little symbols through each line, just like I did up there in red, to show that those sides lengths are congruent. Do this in your notebook and not in your packet, please, so that you have the notes. In the one that's in your packet, what's the measure of this angle right here? 108 what? That little sign right there means degrees, okay? What's the measure of this angle right here? 108 degrees. How about this one? How about this one? How about this one? Are they all the same? They are all congruent. Again, you can do it by labeling, by writing the measurements to show the congruent angles and sides. But another shortcut symbol is we can just draw these little half circles to show that all the angles are congruent. If you are going to draw this in your notebook, right next to it, that is a regular pentagon, because all of the sides and angles are congruent, as evidenced by the markings that you drew. This is still a pentagon because it still has 5 sides. Do you agree? 5 angles, 3, 4, 5, and 5 vertices, 1, 2, 3, 4, 5. However, this is not a regular pentagon because not all sides are congruent. Do you see now how they've used 2 small markings there to show that those 2 top line segments, these 2, are congruent? Do you see how they have 2 lines running through them? However, these line segments down here have how many hash marks, they're called tick marks running through them? How many? 1. So those 2 are congruent, but are the red lines congruent to the blue lines? No. So if not all 5 line segments are congruent, then it's not a regular pentagon. So do you see how you can use the same markings to show which sides are congruent? Yes? Okay. Same thing with the angles. How many half moon shapes do you see on these angles? 2. So does that mean that those are the same angles? If I were to measure this angle over here on the left and measure this angle on the right, would they be the same? However, how many half moons do you see down here? 1 each. So is the green one the same as the yellow? No. So you can see we can use the same markings. As long as you're using matching markings, it shows that those 2 line segments or those 2 angles are congruent. But if they're different symbols, then it shows that it's not. Does that make sense? So we can see that this example right here is a triangle. All the sides and all the angles are congruent, so it is a regular polygon. We can call that a regular triangle. Okay, let's go through the same process for these next ones. Let's talk about this next one, number 2. How many sides, angles, and vertices does it have? Count them.